Hello, Legacy Mathematicians. So today we're going to look at logarithms, which is our next unit, or next section of this unit. You're definitely going to want a calculator today, so you can find things on there, so when we get to class, you'll actually know where they are. And then you're going to need your notes as well, and that little foldable thing that I gave you in class, the little piece of paper. So guys, basically, logarithms. No, they are not logs, and they do not grow on trees. So the new type of notation is going to help us to solve for x. So here's the reason why we're going to look at this. Consider crime forensics, so people who figure out when a person gets killed. So we're going to investigate in murder. According to chemistry reports, this victim had traces of aspirin, which was 300 milligrams, in their blood. Aspirin is known to decay at a rate of 20% per hour in the human body. A friend of the victim saw the victim take aspirin, which is 500 milligrams. They took 2 aspirins, which is 500 milligrams each for the 2 of them together, around 4 p.m. So we need to know what's the approximate time of the crime. So guys, we are decaying, right? Because it's the amount of aspirin's going down. So I do know that she has an initial amount of 500 milligrams, right? Because that's how much she initially took. I know it's going to be 1 minus, and the rate was 20%, so 0.2. And after, and I know it was time t, right? Because we don't know the time. We want the approximate time of the crime. But we do know after time t, we have about 300 milligrams left of aspirin in her blood. So what I can do then is divide by 500 on both sides. So then this would be 3/5 over here equals, and then this would be 0.8, right? 1 minus 0.2. So I'd have 0.8 to the t power. Now guys, can't divide by 0.8 because it's 0.8 to the t power. I can't get to t. I cannot solve right now. With our knowledge, we can't get to t. So let's see if we can use logarithms to help us solve for variables that are in the exponent. So go ahead and grab that little foldable guys out. So logarithms is basically just a special way to ask a very specific question. Now they're going to look something like this. And how to say that, because you're going to be like, oh my goodness, how do we say that? That is read as log base b of a is x. So log base b, so this is the base of a is x. Okay? So something to get used to. So it would be log base 2 of 3 is, and then you would say the answer. So now guys, the question that the logarithm is basically asking, what exponent is required to go from a base of b to reach a value of a? That's the question we're going to want to ask ourselves. And I'll read it off to you when we actually start doing problems, when we start converting. So now, talking about converting, exponential form and logarithmic form are interchangeable, if you must say that. Exponential form looks something like this. You have the base to an exponent equals the value. So it would be something like this. 2 to the 4th equals 16. So here's my base. Here's my exponent, and 16 is the value, or if you would consider it, the answer of the problem. Now, what logarithmic form does is it takes those pieces and moves them around. So logarithmic form is log with the base of the base originally of the value equals your exponent. So what this would actually look like, if I would do this problem, it would be log, and my base is going to be the same base, so basically the big number. So log base 2 of the value, 16, equals my exponent, which is 4. So guys, here's why the question is, what exponent, aka 4, is required to go from a base of b to reach a value of a? Okay? So let's think through that. Let's try this again. Let's look at an actual examples. So go ahead and open that little book there. And let's calculate some following logarithms. So I got log base 4 of 64. And we need to know what that's equal to. So basically, guys, we need to ask ourselves, what exponent is required to go from a base of b, 4, that's going to give us 64. So 4 to what base, or what exponent, excuse me, gives you 64? So 4 to what exponent gives us 64? 4 to the third, right? So log base 4 of 64 would equal 3, because my exponent equals 3. Okay, let's try another one. Log base 6 of 216. So what is the exponent on 6 that would give us 216? So x6 to something needs to give us 216. So 6 to what power gives us 216? 3 again, right? 6 to the third. 6 times 6 times 6 is 216. Let's try this one. Log base 4 of 16. What exponent on 4 would give us an answer of 16? So 4 to what power gives us 16? 2, right? So log base 4 of 16 is 2. X equals 2, if you want to consider it that. Log base 3 of 1 over 243 equals something. So basically, guys, the question we need to ask ourselves is 3 to something has to give us 1 over 243. I can't think of that off the top of my head. So what someone found out then is they went, you know what? There is a way to get logs when you cannot come up with the exponent easily. And it's called something called the change of base formula. You're going to want to write this in the little box, or put it off to the side here and put change of base right here. But how to get it to work out so you can put it in your calculator, because not all calculators allow you to type log base 3 of 1 over 243. You need to be able to simplify it. So log base a of b equals the big number over the base. So for my case, to do my change of base formula, that's what this is called, change of base, I would go log of the big number, so 1 over 243, over log of the little base. So log 1 over 243 divided by log of 3. Now, this is why you need a scientific calculator, ladies and gents. You need to be able to find the log button. Usually, you will find it near an LN button. So do a double check, maybe try to find log. If you can't find him, talk to me. I will help you find him. So it'd be log of 1 divided by 243 divided by log of 3. And I get -5 back out. Now, guys, that does make sense, doesn't it? 3 to the 5th is 243. So 3 to the -5th would be 1 over 3 to the 5th, right? Because you can't have a negative exponent, so we flip it to the bottom. So that would be 3 to the 5th, which is 243. That's how we got that one. So that would be -5. Let's try this one. 5 to some power has to give me 125. So 5 to some power has to give me 125. 3, right? 5 to the third is 125. So log base 5 of 125 would be 3. 2 to some power has to give me 4. 2. You're kind of getting the hang of it, right? 343 to what power gives us 7? Now, this one's probably a little bit, I don't know, Marsh. I have no idea. Let's use the change of base formula up here. So it'd be log of the bigger font number, bigger sized number, not big number, because 343 is bigger, but bigger font. So log 7 over log of 343. Go ahead and do that on the calculator quick. And you get like 0.33333333333, right? Something like that, which is 1/3, right? So 1/3 is my exponent. Which would make sense, right? Because a third is the same as cube rooting. If I cube root 343, I should get 7. So what I'm going to want you guys to do is finish the rest of these off right now. Go ahead and pause the video right now and finish those 3 off. We will introduce them and talk about them in class, okay? Okay, welcome back from doing those 3 problems. Let's now convert between exponential and log form. So, same thing, base, exponent, value. So, to convert to log form, remember it was log, and the base was the base. So I would have log of 1/5. Now 1/5, notice I just kind of drop it and make it a subscript, if you want to call it that, of the value y is equal to my exponent. E and exponent are right beside each other. So equals and exponent are beside each other, if you want to keep that in your mind. Now let's convert to let's convert this one to exponential form. So u is my base, so u to the v power has to equal 15/16. Okay, let's go to log form now on this one. So that would be log of my base, and my base is 9. Remember, my answer is my exponent, so that would be y. X has got to go there. So log base 9 of x equals y. Let's do the other log here. So I got 6 to the y equals x. So log, my base is 6. Exponent is always the answer, or the value. And then the x is the value right there. Then we'll do one more. B to the a equals 123. So log, what would be the base on that log? It'd be b, right? Because that's the base. This, 123, equals the exponent. Now let's do a couple of converting to exponentials over here. So we kind of get used to both of them. So the base would be 7/4 to the exponent, which is y, equals x. So 7/4 to the y power equals x. Base, u, -16 equals v. And then v to the 4th equals u. So kinda, guys, basically it's the same pattern over and over. You just need to make sure you pay attention to the powers. Make sure you kind of memorize the way to do it, because the base is always the base. So if you remember that the big base on the exponential is the little base on the log, that's a good way to remember it. And your exponent is always right beside the equal sign of our log. Now, guys, what I'm going to want you to do is finish those 4 problems converting back and forth. We will check them and talk about them in class when we get back to class today or tomorrow. Now, want to make sure you guys are aware of this. Evaluate log of 100. So, guys, we would have done this, right? We would have gone, 100, well, hold on. I don't have a base. What's my base? Oh no, I don't have the base to this log. This is a common occurrence, guys. And actually, if there is no base present in a log expression, we can assume that the base is 10. So aka, there's a little 10 right here. Okay? Log base 10 is referred to as what's known as a common log. So you might hear that, let's say like on ACT or something, they'll say the common log, because what that means is there's a log with a base of 10. So ultimately, guys, what this question is asking is 10 to some power has to give you 100, which in this case is 2, because 10 to the second is 100, right? So something to be careful of. If the log does not have a base on it, you can assume there is a 10 hiding there and you just cannot see it. And that's the end of this video. See you later, Sabers.